ನಮಸ್ಕಾರ ಎಲ್ಲರಿಗೂ. Good afternoon to all of you. Welcome to Race Academy Bangalore by YRK Mohan. Organic Chemistry Speed Practice Session number 3 on GOC, General Organic Chemistry, some basic principles and purification techniques unit. Very useful for the coming NEET examination 2024 and next coming NEET examinations also. So in this session also again we will discuss about some different questions compared to the questions which we have discussed in the previous videos. Okay, shall we start? Let us start. Yes, see dear students, in this session we are going to observe different questions than the other questions which we have discussed in the previous sessions. Let us see organic chemistry, basic principles and techniques. First question. Yeah. The Lysines test for nitrogen, the blue color is due to the formation of. Observe carefully the question. The Lysines test for nitrogen, the blue color is due to the formation of. As you all know that Lysines test is to be done when we find something nitrogen, other elements in the organic compound along with carbon. Okay, so the test when you do, then sodium metal will be fused with the organic compound containing nitrogen, will be converted into sodium cyanide, and that will be forming ferrocyanide. Ferrocyanide, that is sodium ferrocyanide, finally treat with sodium ferrocyanide with ferric chloride, will get ferric ferrocyanide. I'll let you know what is that. Is we have a formula that is Fe4 FeCN 6 times, that is Fe4 FeCN 6 times, ferrocyanide is 3 times will be there. This we can also call it as ferric ferrocyanide. Ferric ferrocyanide, actually it is a Prussian blue or green colored solution, precipitate. Prussian blue or it is green color PPT, that is going to be obtained in the detection of the extra elements, particularly nitrogen, in the Lysines test. Okay, now what we got is very clear that we have found ferric ferrocyanide. A option is the right option for this question. Next question. The UPS name of the compound given is like this, and there are different options we have. In seeing this one, from OH you have to start that all these things, but double bond is present. To start with OH, where the OH is present, here in the middle present. So you want parent chain should be more, then you start the numbering from right, then you will get the OH is present on third carbon. First carbon ene is there. On the third and fourth carbons we have methyl is there. Let us see this one in detail. What is the structure given to us is, they are given structure like this, and here OH is given. So how you will give the numbering is nothing but you will give start numbering from right side onwards. So if I give the numbers here for this is first carbon, second carbon, this is third carbon, this is fourth carbon, any one you can take, this is fifth carbon. So if you carefully observe the locations of that one, third carbon and fourth carbon, we have methyl groups are, that means this is methyl and this is also methyl. So we can call this as 3,4 dimethyl, 3,4 dimethyl. On third carbon we have OH is there. Okay. Yeah, that's why it's called as pentane 3-ol. But on the first carbon we have ene is there, so we will write 1 pentane 3-ol. So this is the correct name, 3,4 dimethyl 1 pentane 3-ol is the right name of this given organic compound. So what is the right option is option A. Option A is the right answer for this one. Let's move to the next question. The number of structural isomers of C6H14 is, the number of structural isomers of C6H14 is, what is actually C6H14 is nothing but alkane hexane. Alkane hexane. We have a formula they have already given to us, that is C6H14. Whenever they are given this type of alkane that is having the carbon number up to 7, less than 7, up to 7, greater than or equal to 7, less than or equal to 7, then you can use a formula to find the number of isomers, that is 2 power n minus 4 plus 1, where n is equals to 6 in this formula. So number of isomers possible, we can use this formula. So then a substitute, that is 2 power 6 minus 4 plus 1, that is equals to 2 square plus 1. 2 square is 4, 4 plus 1 is 5. That means there are 5 isomers are possible in this alkane hexane. So now what is the right option for this one is option C is the right option. 5 is the right answer and C is the right option for this. Next, the IUPAC name of the given compound. Here compound is given. IUPAC name, there once again they are asking the IUPAC name of the compound. And in this one thing we are going to decide that aldehyde function loop is there, that has got highest importance priority. You can start numbering from left side and you can give up to a bottom side of that structure. Let us see how it can be done here. So here they are given the structure to us. How the structure they are given, first we will take down. That is given like this CHO, and it is one type of branched one given, and this is extending like this, went like this. This is the structure given. So for this usually what we will write is nothing but we'll start giving numbering from left side. Okay, that is 1, it is 2, it is 3, it is 4, it is 5, it is 6. That means 6 are there in the main chain. In this, on third carbon we have ketone is there, on the second carbon we have methyl is there, on that fourth carbon we have ene is there, where first carbon we have all is there. Okay, this can be written as 3 keto, 2 methyl, 3 keto, 2 methyl hex, 4 ene, 1 all. This is the name of the IUPAC name of the given compound. Let us check. So, what is the right answer for this question is for fourth option 3-keto 2-methyl hex 4-enol is the right answer for this one. Let's move to the next question. Question number 5. The lysines extract is boiled with the concentrated nitric acid. As you all know, with the concentrated nitric acid, if you boil the nascent lysines reagent testing halogens, what is the reason behind that one? Ask remains in that it decomposes the sodium sulfides and cyanides in the chemical reaction. So lysines extract, why it is boiled with constant nitric acid? Ask remains while testing halogens, because that halogens you want means you should remove the sulfur and nitrogen elements from the compound. So first option is the right option for this question. What is the reason behind that one? Asked. Good question they have asked. Next, sixth question. Hyperconjugation is most useful for stabilizing which of the following carbocations? Neopentyl, tertiary butyl, isopropyl, and ethyl. When you just carefully observe, in the last sessions also we have prepared that tertiary butyl carbocation has maximum number of 9 hyperconjugated structures are possible. That's why you explain the stability of this tertiary butyl carbocations. Hyperconjugation will be used. So tertiary butyl carbocation hyperconjugation is most useful in explaining this one. So B option is the right option for this question number 6. Next question. Which of the following statements is not true about the partition chromatography? Question is not true. So means incorrect statement. When you see the partition chromatography, mobile phase can be a gas or liquid. That is true. Separation depends upon equilibration of solute between mobile and stationary phase. And stationary phase is a finely divided solid adsorbent. Looking all the first three options are correct only. That means none of the above is wrong statement. So all the 3 statements are correct, A, B, C. So D, none of the above is the right option for this question. Question number 8. The less reactivity of chlorine atom in this vinyl chloride is due to the region. As you all know, double bond and chlorine lone pair of electrons will be undergoing delocalization to give the resonance stabilization. So resonance stabilization is the answer behind the less reactivity of chlorine atom in this vinyl chloride. So due to that, what is going to happen? Carbon chlorine bond acquires double bond character, and shortening the bond between chlorine firmly attached to carbon is not easily substituted. So we cannot substitute chlorine in this condition when you have taken this CH2 double bond CHCl. So second option is the right option. Next, 9th question. Among the following, the least stable resonance structure is? Among the following, the least stable resonance structure. As you are very clear that between nitrogen and oxygen, there will be a comparison called electronegativity. So whenever we have observed this one, adjacent atoms are there. So actually in this structure, adjacent atoms where least stable are there in this one. So first option, if you observe, adjacent to this positive charges are present on adjacent atoms. So where positive charges are present on adjacent atoms, nitrogen and carbon in the first structure, okay, that is least stable. That means there should not be that positive charges on adjacent atoms in any of the structure given to us. That structure can be called as least stable resonance structure. So first option is the right option. A option is the right option for this question. So option A is right one. Next, question number 10. The polarization of electrons in acrolein may be written as we are very clear about that one, is nothing but acrolein is nothing but one kind of alkene and aldehyde based compound. So in this, the CHO group is actually the aldehyde group. That aldehyde group is exerting a negative resonance effect on oxygen. So oxygen has negative charge, terminal carbon atom has positive charge will be there in this one. So that if you just carefully observe, terminal carbon is not negative, is positive, and oxygen is negative. So where oxygen is negative, we will go with that. That is the answer for this one. So option D is the right option for this question. Next, 11th question. Which of the following carbon ions is least stable? Which of the following carbon ions is least stable? This is one more time we are going to discuss the same thing. This is a repetition. As you all know that alkyl groups are there on the negative charged carbon, means carbon ion. More is the alkyl groups, lesser is the stability of the carbon ion. So it indicates that tertiary butyl carbon ion is least stable in the amongst that examples we have in this question. So fourth option is the right option for this question. Next, question number 12. The distillation technique most suited for separating glycerol from spent lye in the soap industry. So this is a theoretical aspect, a conceptual one, which glycerol is actually separated from spent lye by distillation and reduced pressure, because under normal conditions, distillation, glycerol is having boiling point 290 degrees Celsius. That's why it may decompose. So due to that only, we are doing a process called as this technique, distillation under reduced pressure is the technique which is most suitable technique for the separation of glycerol from spent lye in soap industry. So option D is the right answer. Next, 13th question. The correct stability order of the following species is, if you carefully observe this question, we have all the carbon ions is there. Options Roman 1 to Roman 4, all are positive charges are there. But one point is very clear that first Roman, if you observe carbocation, it is stabilized by positive resonance effect. Stabilized by positive resonance effect of there are two CH3 groups are there in this one, first case. So whereas second case, if you just observe second Roman, positive effect of CH3 group and the other groups is stabilized less. That means whenever the stability is causing by for the carbon ion, the stability is due to the methyl groups only. So plus R effect. In this, the decreasing order of stability is going according to the actual list only. First is greater than third one. So first one and third one. So D option is the right answer. So we have D option is the right option. Second one and fourth one, we have carbon ions are there. The carbon ions are said to be not exerting a greater positive resonance effect than others. So 1, 3, 2, 4. 1, 3, 2, 4. Fourth option is the right option for this question. Okay. So let's move on to the next question. Homolytic fission of a covalent bond leads to the formation of. We are very clear about that. Homolytic fission means equally that bond is shared. That means we will get the same number of electrons, odd number of electrons. Equally, covalent bond is splitting, and the atoms joined in this bond will be equally sharing that electron, one electron each or two electron each. It means it is a free radical formation. Free radicals formation is the answer for this one. Next, in hexa 1, 3 diene 5 ine, the number of carbon-carbon sigma, carbon-carbon pi, carbon-hydrogen sigma bonds respectively are. Once again, read the name of the compound. Hexa 1, 3 diene 5 ine. We will take that and we'll check its structure. Structure is hexa 1, 3 diene 5 ine. So this one we will take hexa 1, 3 diene 5 ine. Hexa means you all know there are 6 carbons are there. Okay, in that first one and third one, we have a double bond is there. Remaining are hydrogens. So you can write the hydrogens. So how many hydrogens are there? That many carbon hydrogen sigma bonds are there. It is the meaning of it. So you can count the carbon hydrogen sigma bonds. Carbon hydrogen sigma bonds are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are there. But one more time we will check it whether any possibilities there we have to modify it according to the name. Yes. What is that particular name given to us is in that name 5 ion is also there. We will check it once again. On third one we have a double bond is there. So 1, 2, 3, 4, 5. On fifth one we have a triple bond is there. One more time we have verified. Yes. Now we will see the number of hydrogens. 1, 2, 3, 4, 5, 6. So that means carbon hydrogen sigma bonds number is 6. Whereas carbon carbon pi bond number is how many? In triple bond we have 2 pi bonds are there, remaining we have 2 are there. A total of 4 pi bonds are present. And one more thing, carbon carbon sigma bonds are how many? If you check it, 1, 2, 3, 4, 5. So there are 5 sigma bonds. So carbon carbon sigma bonds are 5, carbon carbon pi bonds are 4, carbon hydrogen sigma bonds are 6. 5, 4, 6. So 5, 4, 6. Where is 5, 4, 6? Yeah, first option. First option is the right option for this question. Next, which of the following organic compounds has same hybridization as its combustion product CO2? So what is carbon dioxide hybridization? Is nothing but sp hybridization. So which of the following hydrocarbon is having same hybridization? Means sp hybridization is present in alkynes. So ethane is the right answer for this one. So how you will understand is carbon hybridization, carbon dioxide is sp. The same hybridization is present which of the options? Means alkynes. So alkyne given in the option is second one, ethane. That is the right answer. Next, move to the 17th question. Which of the following statements is not correct for a nucleophile? For a nucleophile, one statement is not correct. Carefully observe. Ammonia is nucleophile. True. Nucleophilic attacks at low electron density sites. That is also true. Nucleophiles are not electron seeking. Yes, they are not electron seeking. They have electrons are there. They don't seek electrons. Nucleophile is a Lewis acid. Where that mistake is there? Nucleophiles are Lewis bases, not acids. So fourth option is the right option for this question. Next, 18th question. Liquids which decompose below their normal boiling point can be distilled at lower temperature. It's a conceptual one. That is the reason behind that one is the decreasing the pressure. So when liquids with decompose lower than the normal melting points distilled at low temperatures, reason behind that one is the pressure of that liquids is decreasing the pressure. When pressure is decreases, automatically boiling point also decreases. So 18th question, second option is the right answer. So boiling point gets lowered at low pressure. 19th question, a substance containing an equal number of primary, secondary, tertiary carbon atoms is. If you just carefully observe in this one, we have mesitylene is there, and we have methyl oxide is there, malic acid is there, melanic acid is there. In this, we will go with mesitylene. What is the reason behind that one? I'll show you. Mesitylene is nothing but it is 135 methyl benzene. So I'll show you that. So if you take the benzene ring, we have a triple bond is there inside the benzene ring, and their CH3 groups are present here. So we have carbons are present like this. So in this, if you count how many primary carbons are there, there are 3 primary carbons are there which are outside are present, right? So this is 1, this is 2, this is 3. Whereas secondary carbons, how many are there? Means if you count the secondary carbons. So leaving these 3 positions, remaining 3 are secondary carbons. So 3 they are present. What about the tertiary carbons? Tertiary carbons, where we have the junctions are there, the junction carbons are nothing but tertiary carbons, they are also 3. In that way, we can go with this mesitylene oxide in this question. Mesitylene in this question. What is mesitylene? Means yes, 1,3,5 trimethyl benzene. Mesitylene is that one. So 19th question is this. Next, 20th question. Correct decreasing order of priority of functional groups of organic compounds in the IUPAC system of nomenclature. As per the IUPAC nomenclature, carboxylic acids are having a highest priority than sulfonic acids, then amides, then aldehydes. So fourth option is the right option for this question. Next, 21 question. In Carrier's method of estimation of halogens, so 250 milligrams of an organic compound gave 141 milligrams of silver bromide. The percentage of bromine in the compound is how much? If we have mass of silver is 108, bromine is 80. There are 4 options. We have 48, 60, 24, 36. Let us check with this calculation once. In Carrier's method, what is going to happen is to find the percentage of bromine atomic mass by the molar mass of silver bromide, that is 188. That means bromine will be converted into silver bromide into what is the mass of silver bromide is there, the mass of silver bromide by mass of organic compound taken into 100. Actually, it is the formula we have. So in this, if you substitute the mass as given in the question, mass of silver bromide is given 141 and mass of organic compound given 250 into 100, you will get an approximation of 24% in the calculation. You can check it. That is the answer for this question. So what is the right answer is 24%. So C option is the right option for this question. Next, a gaseous hydrocarbon upon combustion gives 0.72 grams of water and 3.08 grams of CO2. The empirical formula of the compound. So whenever they are given masses of this type of compounds, that number of moles of CO2, number of moles of water can be calculated in the combustion reaction, and to find the number of carbon and hydrogens in the formula. Let us check with it as a numerical one. Combustion equations. What is the combustion equation? General formula we have is CX HY plus X plus Y by 4 O2 gives rise to XCO2 plus Y by 2 H2O. Actually, in the question, CO2 given 3.08 grams, whereas water given 0.72 grams. That means if you find the number of moles of CO2, that will be the number of moles of, that will be the actual, the carbon number in the formula. Whereas if you find this number of moles of water, and again from that you can calculate what is the hydrogen number. Okay. Hydrogen number is that only. So we will find what is the X value. So what is X is equals to 3.08 by molar mass of CO2 is 44 and Y is equals to 0.72 by 18 molar mass of water. We will get 0.04 for this one, and 3.08 by 44 you will get 0.07. So what is X by Y? X by Y is 7 by 4. Therefore carbon is to hydrogen is 7 is to 4. Empirical formula is C7 H 8. Actually Y by 2 answer we have, this is 0.04. So Y is equals to 0.08 will come. So 7 by 8, 7 is to 8. So C7H8 is the answer for this one. So C7H8, third option is the right option for this question. Next question. In allene, the type of hybridization of the carbon atoms is usually allene is a compound where we have a double bonds are present on both sides of the carbon, middle carbon. That is how it will be there. Once I will give you, that is a H2C double bond C double bond CH2, that is allene. In this sp2 carbons, terminal carbons are sp2 carbon, middle carbon is sp carbon, that is allene. So what is the right option for this one is sp and sp2. So second option is the right option for this question. The best method for the separation of naphthalene and benzoic acid from their mixture is as it is crystallization, because both benzoic acid and naphthalene sublime on heating. That's why we cannot easily separate them by this method. So benzene is soluble in water, warm water. Naphthalene is not soluble. Therefore, they can be separated by crystallization. Crystallization is the answer for this question. Next. On complete combustion, 0.246 grams of organic compound gave 0.198 grams of CO2 and 0.1014 grams of water. The ratio of carbon hydrogen atoms in the given compound is like the empirical formula how we calculated, similar to that only this problem. We'll check the calculation once. From that data we will take. So what is the number X value from the combustion reaction is nothing but mass of carbon dioxide given as 0.98 grams divided by 44. And whereas Y by 2 from the combustion equation is water mass given to us is 0.1014 grams divided by water molar mass is 18. If you go with the simplification, you will get 0.0056 for water is number of moles, whereas for carbon dioxide 0.0045 you will get 45. So what do you mean by x by 5? X by 5 is nothing but yeah, very simple. That is 0.004 by 0.005. It means it is here also we have to do y is equal to 0.01 only. So I will write 0.01 one more time. Yes. Yes, 0.01. Okay. So what is the answer here? We have so upon substitution y by 2 answer is 0.0056, x is 0.0045. Then if you substitute in that one, yes, we will get yes, I will come to that point. X by y is answer is 4 by 1000 into 100 by 1. So 4 by 1000 into 100 by 1 is how much? 4 by 10. 4 by 10 is how much? 2 by 5. So x is to y is how much? 2 is to 5. 2 is to 5 is the answer. So what is the right option we have? Is option C is the right option for this question. Next, 6th question, 26th question. Which among the given molecules can exhibit tautomerism? Same model we have already observed in the previous session also. For this one requirement is there. What is the requirement is alpha hydrogen. If the alpha hydrogen is present and the bridge carbon never participate in tautomerism, therefore only third option can only exhibit the tautomerism. Remaining two, first Raman and second Raman, they don't exhibit tautomerism. Next, 27th question. The principle involved in paper chromatography is actually paper chromatography is a partition chromatography. So partition is the principle involved in that one. Next, 28. The increasing order of the boiling points for the following compounds. You observe, first one is alcohol. Second one is haloalkane, ethyl chloride. That is yes. We have propane. We have ether. So from this one thing we understand that alcohols are having higher boiling point due to hydrogen bondings C and D. In C and D only we have such type of difference is there, and that can be easily understood when alcohols and ethers are there. They have higher boiling points than their haloalkanes and alkanes. So in this case, we can take molar mass also in consideration. In such a case, ethyl alcohol is higher boiling point than chloroethane, than ether, than alkane. So 3 less than 4 less than 2 less than 1 is the right answer for this question. Fourth option is the right option for this question, 28. So in this, hydrogen bonding is one consideration, ethers are volatile, and whereas this ethyl chloride is there, that has greater molar mass. Next, 29. Identify the compound that exhibits tautomerism. Yes, in this one thing we can understand that tautomerism is a characteristic property of carbonyl compounds, ketones, and ketone-enol tautomerism, ketone-enol isomerism. That is possible in ketones. 2-pentanone, we can easily do that one. So alpha hydrogens and saturated carbon are there. They show tautomerism in the 2-pentanone is an example, whereas the others we don't get that thing. So 2-pentanone exhibits ketoenol tautomerism in this question. Second option. Next, 30 question and the last question of this session. Which of the following is a non-benzenoid aromatic compound? Non-benzenoid aromatic compound. Benzoic acid, benzene ring will be there. Naphthalene, benzene rings will be there. Anthracene, 3 benzene rings. Naphthalene, 2 benzene rings. Benzoic acid, 1 benzene ring with carboxylic acid. So we have to suspect the tropolone. The tropolone is actually a 7-membered ring. We'll check its structure, how it will be there. Tropolone is a ketone. It will be like this. Actually, internally we have there are 3 pi bonds are there like benzene, but and these 3 pi bonds are there with along with we have one ketone, one alcohol functional group is also present in this one. So all the carbons in the ring might be sp2 hybridized, but these are not delocalization. Delocalization is not going to happen here. That's why we call propylone is yeah, delocalization also happens. Also, it's giving a different answer according to Haeckel's rule. But it is not a benzene ring. So simply we can call this is non-benzenoid compound. Non-benzenoid compound. So 4n plus 2 is satisfying. Sorry, 4n plus 2 is definitely satisfying. It has some 6 electrons are there. N is equals to 1 is coming. This is also satisfying like others. So benzoic acid is there. We have aromatic compound, aromatic aldehyde, benzoic acid, aromatic carboxylic acid. That is benzoic acid. They have given, yes, benzoic acid is one option we have. So COOH, aromatic, benzene ring is there. Naphthalene, there are 2 benzene rings are there in naphthalene structure. There are 3 benzene rings are there in anthracene structure. 3 benzene rings when they are fused, that is anthracene, this is naphthalene, this is benzoic acid. All have benzene rings are there, whereas this tropolone has no benzene ring, but it is aromatic. Okay. So dear students, I hope you observed this session. In this session, so many repeated concepts, interesting questions, different type of model questions are discussed. in this session from GOC. Definitely we'll expect 2 questions from this GOC this year 2024 NEET examination. I hope you understand this explanation, and any one of you need the same questions, you can just pause the video and see the questions and prepare that model questions in your materials. Have a nice day. Thank you very much.